Hello world, Great Giza Pyramid. Thought I'd make this one a little bit more interactive today. So if you whip out your cell phone or a laptop, or just minimize me, push me to the side and pull up Google Maps and type in Giza Necropolis. Or you can type in those GPS coordinates right up there, and let's get you to a spot where you're looking at the Giza Plateau. Now, the way I understand the system is thus. If we take on the Giza Plateau and it's going to drop you right here, you go up that road to Khufu's Diner there, and you go around the side of the mountain from Khufu's Diner, you come to these big things that look like the water flow controls in the LA River Basin. Something out of the Terminator movie where they're driving around coming out of those big holes. Well, that's what you got over there. And I believe these are to help feed and maintain the water level of the pool that would be up there to feed the system. Now that's at 82 feet in elevation. And anybody who wants to confirm that, I ask you, please, you and a friend, don't go alone, because if you trip and fall, there's no one there, and I don't want to be responsible for your death. But go with a friend, put your cell phone there, get the GPS coordinates, get the elevation, snap a picture of it, do screenshots, whatever, back up and document which one you're at. And I want to find out if each of them are the same elevation, because that just kind of adds credence to it. Or it looks like there could be some dividers, so they could be at slightly different elevations, and I'd like to confirm that too. So please work with me, find holes in my feelings, or help me confirm them. Either way, 82 feet is the feeder. So at 82 feet in elevation is where we have our water source. So right here, we're going to put a pool. Now that water source is going to do a couple of things. Number one, they're going to bring a canal, and you can kind of, if you look there, see there's a line between the different sections of the Osterbos. And that's going to be a canal that comes over at the 80, it's actually going to, only needs to be 80 feet, because the entrance into the Giza Pyramid is like 19, 20 feet. Again, take your cell phone, bring it up there, put it on that little lip, and give me the exact elevations, because working out the exact numbers helps me get the head pressure, the water pressure, which is going to help me actually fine-tune this to get the true measurements of what was occurring. Well, if my fish story is correct. So anyway, 80 feet is where it's going to feed into the pyramid, this section right here, when we get to that. But we're looking at the water flow on the outside right now, so ignore all that. We're just looking at the water flow on the outside. It's going to come over and feed that. Now, that I'm going to suggest to you kind of comes this way and feeds it. Now, as it goes on, I think we're going to find that pool was expanded to go around at least these two sides, and then the runoff would also feed the areas over here. I don't think it fed this area. I think that area is being fed from here, but we'll find out as we do more Randall Carlson type research and look at the topologies and water flows and understand what was going on. Now, some of this was elevated and off ground, and it's by deduction that you come to this, because there was something that fed the system, and I was looking and looking and looking till I found these at the 82 foot mark, higher elevation than the entrance. It's only logical that was our feeder. So anyway, water comes down, feeds there. Now the rest of it actually flows down. It's going to go into what I'm going to call right now the gauntlet, that whole area that like to call the mastabas. You got some over here and you got some over there. And it's going to go into the gauntlet, come out of the gauntlet, and then, like I said, it's going to, oops, wrong color. It's going to flow down around there, feed over. Now this feed joins the feed that comes out right here between, here, I guess the best way is if we can zoom in over here. Between these, the three, what they like to call the assisting pyramids, Queen's pyramids, whatever they want to call them, and for whatever reason my thing's not zooming in, so I'm not getting a good control. You can see between the two of them there is a flow that came out there, joined here. That came over and would actually come down to the side. You can see it actually kind of came this way into the side, across what's today the road that flowed over down into the Sphinx Pool and then filled that out and into the Nile River and out of the system. Now there was a separate one that came down out of the gauntlet, comes and it joins with the flow from over here that comes down that little rocky area. And we're going to say the elevation right here, like again, somebody wants to put their little cell phone there and get me the exact measurements, we're going to record that currently at 65 feet in elevation, because at least that's what the documentation says and all the topology maps. But we're going to work with getting the fine exact numbers because, well, physics doesn't lie. Well, you can get physics to lie, but physical science doesn't lie. Actual, on the ground, doing something, physical experiments. Anyway, so that elevation pools over there. It also comes over here. This side it comes down, joins into the pool that's here. Part of the Osiris shaft thing, which is the actual only ground, the true ground in the system that goes down to the water table to this very day. That is this part of the system right there. That's the Osiris shaft. Okay? Now it has a bunch of jog handles and turns and stuff, but some of that is function and some of that is communication. We will get into that deeper, and being that is the shaft deeper. And then it comes down. Now here, it doesn't do any waterfalls. It seems to pool and flow to another pool. You can see pool, flow to another pool, and then it looks like it rejoins here, comes over, spills into that area, and then again rejoins the Nile River. This one, however, it has like a little waterfall there, and then definitely has waterfalls going into this the Sphinx Pool. It comes down this way. This is a facade ground. This ground does not go to the water table, but it goes very near it. That is that huge hole right here. Okay, that's part of the system. And from there, it, like I said, joins there, goes in. Now these stay separate, and you notice when it comes into here, it also goes down a waterfall. Anytime there's a waterfall, there's a break in the circuit. So this pool here, this entire pool here, which kind of trickles down here, all this pool here is grounded via the Osiris shaft. This pool here, which is breaks the circuit before it goes into the Sphinx Pool, as it goes down that waterfall. This one is all, I'm going to suggest it has a little waterfall when it comes out of the gauntlet. This one is semi-grounded on this side of the equation, and this one here, it's actually connected to this pool and this circuit, and again it breaks when it goes down there, and that is one. Now this also is going to short to the pool that's over here, and there's another pool here, and the elevations we can measure when I get the elevations of the mean elevations of the mastabas in the area. That'll tell me well, I'm trying to assume it will tell me as I read the system. I'm trying to actually use some of Karl Monk's thoughts on how to actually read the system, kind of like Braille, but it's more than Braille because there's elevations and visuals. The shapes also help with it. But that's again part of my fish story, and I'm working on that part of the story, using this as like a Rosetta Stone. But this pool here, I was telling you about this gauntlet here. Let's talk about the gauntlet. The water comes down here, and it comes into another pool. Now this, we're going to say, is 82 feet in elevation. It's going to fall down a waterfall into another pool at about 77 feet in elevation, and that is going to be about here. In the oops, I need to zoom out a bit if I want to look at it on here. That is over in this area. These right here, you look at the elevation of those. I'm not going to actually do it as it is because it is on a slope, but I'm going to do it visually where you can see it. It spills into a pool, breaking the circuit so that the circuit within this pool is separate from the one that is the feeder, because again, anytime there's a waterfall, there's the break. The water is not shorted, there is a break, and or a spark gap, whatever you want to look at. If you're looking at a car thing, or a arc gap, if you're looking at like an arc light, whatever you want to look at it, there's the gap separating it. So this pool right here that comes down and joins there, actually, that's the out. The in goes into there. Now these would have your mastaba things in them, okay? No problem, they're in there. And you notice that some of them have holes in them, and some of those holes go down and somewhere else. Now I'm going to give you a quick scenario. When you add it all up, there's about 17 different pools at about 11 different elevations, and we can even, I'd love to argue with somebody and figure it out, because the truth is there. I'm just pointing things out. It is designed to fill this pool. That pool actually shorts to another pool in the back, and it does that so the pools in the back are still water, where the pools in the front are the functioning water that get the elevations and such. But that pool spills into here, fills this pool, and then from there spills into another pool about 2 feet lower, and so on and such forth. Well, all right. Now I'm going to regroup right here. We had discussed the coming in at the 80-foot mark. Now I'm going to expand on this because it makes it easier to draw. We're going to draw the 82 feet in. The 80-foot mark is where it has to go. It melds with the pyramid itself. So our water source is up here. All right. Now we have a 70-foot mark, a 65-foot mark, and a 60-foot mark. Those are the elevations of each of the pyramids, 60, 65, 70. Now, we're going to focus first on the one in front of the pool in front of this pyramid. It has a lip of about 72 feet and a depth going down to about 68 feet, if I remember correctly-ish. Okay? It's not very tall. It's a very small pool. Now, I'm going to suggest to you, because you kind of have to work with me, that this is a denser than standard ambient water liquid. Because the only way this gauntlet that I'm discussing really works is that way. On the other side of the equation, let's move this out of the way because we already discussed that trough. Over here, in fact, if we take this pool, you noticed if you look at the pictures on Google Earth or Google Maps, if you take the road out of the picture, there are 2 rails and a very flattened surface. Those 2 rails are here and here, and then that area is a flattened surface that goes up until it starts going up in elevation. That, I'm going to tell you, is because the conduit that goes underneath the ground between this pool and its source over here is like a high power line, and they're suggesting people to stay away from it, because if you walk on there and you happen to be a tall enough person, you are going to be the shortest, the least resistant path between what that water wants and its goal. And well, this is more confirmation bias that we are working with a system that is utilizing and understands electricity. But you know what, I'll leave those little, you can look at them. You can look down here on your own little map. You can see very distinctly these marks. I don't have to make them up, they're there. Okay? Why are they there? I'm giving you a suggestion. You can come up with your own theories. This is mine. That lead will actually be coming from a pool over here on this side, that it itself has a higher depth, but not a very much higher depth. And what they're doing is they're putting a heavier liquid in there, and the other pools, let me just stick one of the other pools in here. This is the lighter water which fills this pool. This pool shorts to that pool, and when it does so, the lighter water is going to ride on top of the heavy water. It's going to add a little bit of weight to it, which will push down a separate shaft that comes over to here, right underneath the ground, right through these high, the area there to that pool, and it will elevate this water above its norm because it's going to add light water weight. So it's elevated above its norm, but it can't go too far because the depth of this water is going to allow it to push the heavier water. I'm going to use purple. The heavier water, this is why, is going to fill this pool, and the heavier water is going to get pushed down like a plunger. And by controlling, that's why I said there's like 17 different pools, by controlling how much light water is in here will control the depth or the elevation of this water in here. And whatever it is, it has to be a different density water for this system to work. Now, like I said, there was the functioning pools and the still pools. That's because this water here needs to not have ripples or anything, and I'm not even opposed to the fact that this area here may have had a covering over it or a building over it at one point, because I don't think they want a bird or anything flying into this area. They want this water to be as still as possible for the reactions they're working, and or they need to control it. But this conduit is going to wind up being a hot conduit, which is why it's clearly marked until the hill starts to go up, and then the conduit continues, and you're no longer the path of least resistance because there's now more ground between you and the conduit. The 17 pools that I was talking about, only at about 9 levels, are because they're dealing with heavy water, and they keep repeating this pattern of putting water on top of water and pushing down, kind of like a plunger. By putting one water on top of it and raising it, it's going to push down on the other one, which raises the water in its adjacent pool, and that water again pushes down on the other one because it adds more water pressure, because now you've elevated the water level, so it's going to equal it with the other one. Now, the only way this actually works is if this water was slightly more dense, and or maybe it will work with light water, the whole math, but I would think that if it was working with light water, that water is always going to find its balance, and this would only work if it was a more dense, and or instead of when it reaches its peak point, it has a equal on the other side, and it just overflows out. That's another option which will keep it from spilling over, because it doesn't look, I don't see anywhere where this water was actually flowing down other than like fluke rainstorm or when something became unequalized in balance. So that's the pool outside of here. This pool, like I said, it's going to come at the 65-foot mark. Its feeder is about 70 feet, where it comes in through the hole on this side, the west side. There are holes in the wall. Those holes are about 5 feet above ground, so they're about 70 feet. So if I was going to draw, they're going to be about 70 feet, and the water spills out of them into the pool, which is at 65 feet, which then spills over in the 2 spots I suggested, here and here at 65 feet. But that will allow this to pool. You also notice that the way it is shaped there, as it comes outside of the pyramid grounds, it comes down and then is flat. Then you have the area where, it's actually in the wall, where I'm suggesting the water spills in to this area. So the pool of water is actually maintained away from the structure. It doesn't come up to it, it goes away from it. And it is maintained at an elevation which is such that it is, the edge of it doesn't actually get saturated. It's a interesting design, and we'll probably understand more when we truly do any research on this. But again, that pool will be maintained and spilled over. Now, on this side of the structure, we have the canal that came, this canal that feeds into the structure at slightly below that, so there's a little bit of headway, and that is going to have the air, actually oxygen, that is coming out of the system, fighting against it to create the oxygen bubble that I've talked about in so many of my videos. That if you haven't seen any of them, we can rehash that. But that is the part of the system down under video, and any of the videos I've done in the past half decade, because it just is. So that is how the gauntlet is functioning, and kind of what it's doing, and what the elevations there are to maintain these. And like I said, there's about 9 different levels, because it looks like they're tweaking it. They have a method to their madness. Exactly what they're doing, not quite sure. And part of the also reason is because some of the pools may be, I'm going to say, hot, and then they may short to the other pools that are just maintenance for the pressures. Now, let's talk about the 60-foot mark. The 60-foot mark, we're going to talk about the structure. I've nicknamed Karen's pyramid. Caitlin's got the rock garden on top of the Great Giza pyramid. Karen's pyramid, that one, when you look at it, its feeder is actually, it's about 20 feet tall. So let's put its height. Let's go ahead and put its entire height. That's fine. It's going to be 20 feet tall. And that is this one right here, which is this one right here. They like to call that the Pyramid of the Queens, Henutsen. Okay? You can find that on your own. Now, what's great is if you take your Google Guy and look inside that, that's what we're really going to be looking at right now. Take your Google Guy and look. Why is he not going where I want him to go? Or her, it, whatever. Inside the structure. See this? This is what we're going to be discussing, is this whole shape. The feeder comes from elevated mark. It's about 6 feet in elevation, so that would put it up here in elevation. And that is where it feeds down into the system. I'm going to make this tight because, well, I didn't give myself much room. It feeds down into the system, and it feeds below ground level. I don't know if you can see it on your video, but I've done a video on this. Right here you can see the mark of where it would come down. These broken pieces that are there and on the other side actually filled this, and you can see the watermark brought it down. So the water on the outside is acting as a pressure plunger, putting pressure on this water. This would be the pool that I said was out here. Okay, you look at the Google Maps, you see all the mastabas there. That is a pool, and it's giving you representation of its elevation is what I'm suggesting to you when you read it kind of like Braille. But either way, it's my fish story. It has a elevation, but the water doesn't need to fill the pool. It only kind of needs to fill the upper part of the pool, because that's where the water pressure is. Anything below that could be dirt, it could be whatever. I don't think it really matters, because, well, it may matter. So let me not exclude it. But what we're looking at here is the water level on the outside has to be enough to fill into this pool. And it may be a pool maintained at the same elevation, slightly below, maybe a millimeter or two, slightly above, millimeter or two. Some of these things may come into effect. Could be a foot, could be a couple inches, doesn't matter. as the water that spills into the second, the middle pyramid, from its feeder, which is, I didn't discuss that. It's another conduit, and you can even see when you look down upon it, its path, because it's semi-marked, to come over and feed. And it may potentially somehow be that same one. So maybe they're spilling hot water into here, charged water into here, and that charged water may be doing something. Again, this is where we need to actually focus on it and look at it like a big circuit board. And where is it shorting? What is it doing? Because they are playing with electricity. Anyway, let's get back to here. It is adding pressure to a water which is within this room, and it's adding pressure to it. What I feel is this structure is reversing the pressures that we exude upon it within the structure, within the Great Giza Pyramid and within the other two structures. But let's focus on what it's doing. It is going to raise the pressure of the water within the pool that is on this side, which is the out, which if you take your Giza guy and you drop it between the two, you can see, I guess we have to drop it over here because they don't have a path over there. You can see, it's not where I put it. I want to be over there. Sorry. This is what happens when you don't cut and paste and do these things ahead of time. Well, if you can get a person, and I had at one point a photo of it. Oh, those lights are right in the way. There's an opening right back in there, right at ground level. They put a grate over it. That opening is at ground level. So, and actually, if you look at the ground, it goes down a bit. So I'm going to say it's at like the 58-foot mark is its entrance. And it is slightly above where this plunger comes in. So whatever liquids are in here, which may or may not be a more dense liquid, I think when this system comes into play, we are working with a more dense liquid, heavy water, D2O instead of H2O. Either way, it's raising the elevation of that water level by having this water push down upon it. It's acting like a plunger. It's the best I can assume. You can look at that room and make your own assertions. It actually goes out of the room. There's an area for air to be in there, and if you look really closely, I already left it, but where it comes in, there's also a conduit that comes out of the wall, and I believe that conduit is there because they need to feel the pressure that's in this room and equalize it with one of the other structures, because this is one of the controls. This is also another control, that the pressure of that water, the elevation of that water. It all comes into play, and they did it all organically, actually using a conduit, so that the pressure in one will raise the other one. It's a control. Where it controls, I think that one actually goes to the inside of the second structure, down at the bottom, where you have that shape. You have your one conduit here and some stuff there, and the other conduit here. This is set up to maintain a pressure in here. When the pressure goes up too much, it escapes out. It has to go somewhere. It may feed here, add pressure, the air bubble comes out of there, comes into here, bubbles into here, pushes down, adds a little more pressure. That pressure goes up. That is going to change the difference here because we're adding elevation to the water on the outside of the structure. Even if it goes up a quarter of an inch, it's raising the elevation just above that lip where it spills down. That may potentially somehow in the whole world of the butterfly's wings affecting somebody on the side of the earth make it so that that water doesn't have enough or doesn't have as much flow over. And because it is shorting to the inside, it may do something to the water pressure here. May as it bubbles, set a little ripple, so more comes off, or just for a brief second, none comes off. And that brief second none comes off, you know, we may get a abundance of electricity, and maybe like a little spark gap, like you do when you're playing with a Wimshurst generator, a Van de Graaff generator, or, you know, any of those sort of things. Anyway, that's my story of the water flow and how the water flow is working. We can, and what these mastabas do and what they function and how they're working. And you know, it's so nice how my fishtail has so much documented backing of physical things upon the plateau. I don't have to modify or change pretty much anything. Please, tell me how big my fish is.